Yay! Milton, good to hear you. We saw your face during the last show.
Thank you.
But where are you based?
Right now, I'm in North Carolina, United States, but I
Right.
joined Slooh originally from Bolivia, South America.
Oh, right. Okay.
And
listen,
I'm a huge fan.
I'm going to leave you in the hands of Russ for a minute, because I've got to do some trickery behind the scenes to get all of our feeds and stuff like that set up. But anyway, good to meet you anyway, Milton.
Absolutely good to meet you too.
Excellent. Yeah. And for everybody else, you know, the chat, and we've got Lourdes, who just said chat's okay for questions. So yes, definitely chat will be great for questions. You can also hit the Q&A. We've got all those windows open. So, you know, ask away, ask the questions that you have. Now we'll work our way to getting to all the questions that we can, and or, you know, as quickly as we can. So, but yeah, but if you know, hey, if you do want to ask a question live on air, we can promote you just like we promoted Milton. And we can bring you up here and you can ask a question. But if you're better off just chatting it or Q&Aing it, that's good too.
Yeah. So and we may it depends how many people come in, but I think the other day, last night actually, for Mike Shaw's Nightscapes Star Party Live, we promoted everybody in that. So because it's kind of nice. One of the things that we can't do that we did in the last Star Party is we don't see everybody's video automatically. Everybody has to be promoted, which is not a bad thing, I think. But it's quite cool to be able to see everybody. So depending upon how many people would come in, Todd, who's working in HQ, thank you very much, Todd, for helping us out tonight. There he is. Hello. We'll probably try and promote people, won't we, Todd, so that we can see everybody?
Yeah, if you want me to, I can go ahead and
yeah. If everybody can, though, mute their microphones. Otherwise, there's a kind of, we can get a build up of background noise coming in.
Yeah. So Nadine 1848 just asked, wondering if she's hooked up correctly. It's the first time, so I think you are. I mean, if you can see us and hear us, then you're hooked up correctly. That's and until you get promoted, you're just behind the scenes. It's a webinar style, so slightly different than the Zoom that we're all getting used to here. So, but now you're getting promoted.
Hi, Nadine.
We can start seeing your faces show up. Hey, so yeah, I think we're doing great.
Hey, Bonnie. Hey, listen, you can unmute yourselves because it'd be quite cool to hear where everybody is kind of watching from tonight. So kind of you can go along. I'm gonna start screen sharing now. So Russ, if you can keep an eye on Q&A, because my screen's gonna kind of be full with my screen share.
I'm gonna be on Q&A. I got it. I know my duty.
And Paul, you still good with the YouTube side of things?
Yes, YouTube. I'm just starting that up. So we should have YouTube is started, Facebook is started. And let me get this horrible little menu out of the way. And I think we can probably start Twitter off as well now, and then I can put that to bed, which is quite good. I can pause that to save some bandwidth. Sorry about that. I was talking to myself there, but realizing that, you know, you lot are in here as well already. So anyway, where's everybody from? So Milton, we heard from North Carolina. Nadine, if you unmute yourself, there's a little button that says unmute. Tell us where you're from. And Bonnie, tell us where you're from as well.
I am originally from Minnesota. I'm now currently a resident of Florida, and I'm a full-time RVer, and I travel the country all months except those few lousy winter ones that we all bundle down for.
Okay, well, good to meet you anyway. Bonnie, how about you? Where are you watching from?
I'm watching from Texas in the United States, and I'm originally from Ghana in West Africa. I'm with the U.S. Army, and I've been traveling around, going to different places, and I'm happy to meet you here.
Great to meet you as well.
Nice.
Hello, everybody.
Great state of Texas.
Anybody, we are now live on YouTube, on Twitter, on Facebook. Todd, not sure if you can just check those for us, making sure they are live. Let me just check. I can check Facebook. Just so anybody who's watching at the moment, we're just getting ready for our live Star Party. Star Party Live. We're going to start in about 1 minute's time. So let me just check this.
Great. We got James with us from Seattle, Washington. Welcome, James. Glad to have you here. Starting to get into the beautiful time of the year up there in Seattle, right?
Welcome, Divya.
Yes, we're live. Okay, folks, we are at the top of the hour, so welcome, Slooh members, you lot out there, to another Star Party Live, Slooh Star Party Live, and tonight it is the super flower moon. I'm Paul Cox, Slooh astronomer, Paul Cox. You'll see me in the community, hanging around. I usually whiz around the observatories as well, installing equipment and stuff like that, alongside our Slooh operations manager, Andrew Dumbleton, who is looking after one of the new telescopes tonight. Now you can see, actually, you lot tell me, can you see my browser window? I am sharing my browser window. Can you see that? Russ, can you see my screen?
Oh, I've got your screen right here. Yes.
Great. Okay, so
Good.
here we
Looking
are on the Slooh homepage. Let's hop over straight away, actually, to the shows page, because I want to show you something. So if you go to the shows page, I've got to watch that I don't get some feedback here, so I probably need to turn the video off. But this is where you watch a show. So there it is. Oh, there you go. Muted myself very, very quickly there. But look, what you can see here is up the top, we've got these other tabs. Now, if you click these, we're going to have a look at the conditions properly in a minute, aren't we, Russ? But there's your sky camera. And this shows actually one of the only times when you can watch or snap an image from the all sky camera. We'll go over that in a sec. But anyway, there is that moon. Let's go to Canary 2 ultra wide field, because this is going to be the telescope. Oh, wow. We are going to talk in such a lot of detail, aren't we, Russ, about what we're seeing. But I mean, just your first impression there.
It's amazing. I mean, it doesn't get any better than that, right?
I've got to snap an image of that. Ooh, look at that. We are going to talk about some of, actually, we're going to talk about later on the Lunar Features quest, because anybody who's done that quest, I can see immediately that there are 2 features that we talk about in that quest. Quest is an activity. If you're new to Slooh, talk about that as well.
And right, I mean, the moon it's like a work of art, right? Our eyes are pulled to certain places on it, and we're going to talk about those places where our eyes are pulled, and then we're going to take a look at some of the other things that maybe where our eyes are not pulled, and see what else is going on there. So,
but there's a couple of things that are specifically good to look at. A few features that are good to look at. Here's a close-up of the Canary 4 Solar System Telescope. I'm going to take a snap of that as well. I'm getting slowly to the one that I wanted to get to. Chile has just come online. Now, if we're lucky here, there it is. It's already risen, in fact. Now, I'm going to snap an image of that because hopefully anybody may have... All right, that's above the horizon. We've got it above the horizon. Now, oh, this is really exciting, right? Now, all of you, and I can see you, so you've got to do this. Turn your heads to the right. All right. You can see at the it's then on your left, top left-hand corner, in other words, of that image, there is a dark patch. Where has that chunk of moon gone? Well, I can tell you. That's the Andes Mountains. We have just captured, you've got to snap an image of this quick, because we have just captured the moon rising above the Andes Mountains. I was so hoping this was going to happen. Russ, is that the first time you've seen that in the Slooh scopes?
It is indeed, yes.
I mean, normally you see, when the moon rises in the Canary Islands, we can look below the horizon. The Canary Islands is so high and we're looking over the ocean. So it kind of just comes out of the mist, out of the kind of fuzzy horizon. But here we've got the super flower moon rising. It's about 14 degrees above the horizon, and that is the Andes mountain range. So then when the stream continues, we'll see that chunk of moon appear. But this was the one that I actually wanted to get to, the Chile 3 Lunar and Planetary Telescope. Now, I don't know if this is going to work for me at the moment. If it doesn't, I've got another way of doing it. It's the first time we try to use this. Right, I'm going to go back to, Canary 2. I'm going to see if we can get this video up. Now, this might take a bit of bandwidth. So if this comes up, this is going to be the live video feed from, oh, there it is. Let's go to theatre mode. Hopefully you can see this. This is the live video. So this is a live video from the Chile 3 telescope. Now, we had a few problems with this a couple of weeks ago, but it's back online now. Andrew Dumbleton, who's Slooh's ops manager, is operating this for us tonight, and he's captured it. This was really difficult for him because he had to point this telescope with a tiny field of view. You can see how much field of view there is there. And he couldn't point to it until it rose above the Andes Mountains. So Andrew is going to scan over. Hopefully it will come live, actually. This is going to have its own telescope page in the end. Hopefully this will come live on the show page. But until then, Andrew's going to kind of go around a bit. What do you think of this then, Russ? Quite cool, isn't it?
I mean, it's fantastic. It's fantastic. I just can't wait to talk a little bit more about it, get some of our community discussing it too, you know, asking some questions, but also putting they're giving us their input, you know.
So tell us this then, Russ, to start off with. We'll talk about the supermoon in a minute and the actual phenomena, but while we're looking at this, we know that tonight is the full moon. So it's the full flower supermoon, right? That's when the whole of the moon is illuminated, but I can see there's some shadow down the bottom. So it's not fully illuminated. What's that about?
Well, yeah, I mean, whenever you've got, you know, really whenever we're looking at an object in space, we're looking at the reflected light from the sun. So, you know, full moon is when we're getting that face that's toward our planet, and it's tidally locked. So we see the same face all the time. It's rotating at the same time it's orbiting us, and so we see that same face all the time. You know, it's getting the full light from the sun on it, that face that's toward us, and so we're getting that full reflected light. But there is a backside to that moon, and we're seeing that edge right on there.
And I'm just starting up a little program that I run, and it's called Quick Phase Pro. I can't share this with you as well, but what I wanted to look up is the moon is fully illuminated, but only at the precise moment of full moon. So I'm just looking up to see exactly when the time is, and it's at 10:46 UTC. So it's about another 10, 11 hours before the moment of full moon. So tonight is the night of full moon. So in theory, this is still a waxing gibbous moon, but it's the night of the full moon. So that's why we're still seeing a very, very slight phase on it and some of those shadows down the bottom. So thank you very much, Andrew, for kicking us off with that. Now then, I'm going to close some of these things down. Listen, has anybody got any questions for us yet? And then I think, Russ, we probably ought to go into explaining what a supermoon is. I got carried away, sorry, with lots of pretty pictures.
Well, it's easy to do. I mean, this is what we're all here for, is to get carried away with these pretty pictures and then to dig a little bit deeper into them, right?
Exactly.
So that's okay. We'll keep going.
Okay, so supermoon. A supermoon is bigger than a normal moon. We got an interesting poll that we're going to bring up a little bit later because we want to hear your views on the term supermoon. Is it all hype and stuff like that? But Russ, why does the moon change size?
Yeah, so the moon is not in a circular orbit around the Earth. It's in an elliptical orbit, and it's fairly significant in that when it's at its closest point to us, it's 40,000 kilometers closer than when it's at its farthest point. That's about 25,000 miles. So, you know, you're getting a big difference between apogee, which is its farthest point away from us, and perigee, which is its closest point to us. So yeah, we get the mini moon and the super moon, you know, the super moon having the extraordinary superpower of being bigger and brighter. And then, you know, the mini moon when it's at its apogee, which is so farthest away from us. So it's all part of that, you know, elliptical orbit that it has around our planet. And
they tend to come in pairs, or this one's a trilogy. So this is the last of a series of 3 supermoons. The last supermoon last month was the largest of 2020. This is the last supermoon of 2020. Now, a little bit later on in the year, we get that other phenomena that you're talking about, when the full moon coincides with apogee, when the moon is furthest away from Earth in that elliptical orbit. And I think there's 3 of them. I think it's around October. It was maybe September, October, maybe August, September, October. Maybe somebody confirm that in chat for us. Now,
and we should, Paul, we should celebrate those too. You know, we really we celebrate these super moons, but we should really celebrate our mini moons too. I mean, you know, the moon needs to be celebrated at all times. At all times.
Exactly. And actually, I'm really looking forward to a mini moon, because a mini moon brings 2 of our other telescopes into these kind of events. At the moment, the moon would not fit within the Canary 1 or Chile 2 field of view. In other words, it would kind of spill over. But a mini moon is just slightly smaller so that it does. But what I'm going to recommend to people is make sure that you snap loads of images, especially from the Canary 2 ultra wide field, because this is the only telescope tonight that's giving us the whole moon. The reason why I'm saying snap these now is that you're going to get an image of the supermoon. Then come those mini moons, we'll do it again, and hopefully you'll be able to see this. You will then be able to generate something like this, your own comparison between the perigee moon and the apogee moon. And I don't know if anybody saw my tweet. I think it was yesterday or this morning. But I said in my tweet, don't believe anybody who says you cannot tell the difference between a supermoon and a mini moon. In other words, that apogee moon and the perigee moon. But anyway, Russ, have we got any questions yet?
Well, we've got we do have a question.
Nadine is putting her hand up. So unmute yourself, Nadine, and ask away.
Thank you. I am not able to snap a picture. Am I doing something wrong?
Right. If you are on the show page here, if you go to these other tabs, so you're probably watching, sorry, I've got a lot of things on my screen at the moment, but you're probably on this screen here that says show that I've actually paused. If you click these other tabs up here, that will open up each of the telescope views that we've got tonight. And then you should see this view and you should be able to then snap an image. Have you got that?
No, it still doesn't seem to be working for me.
Okay, we'll have to pick that up. We'll have to pick that up separately. I mean, do you see these other tabs up here?
I do. Yes.
You do.
All 5 of them. I do.
Okay, and you see the little camera button down there?
Yes, it's red. Mm-hmm.
It's red. Okay.
Yes.
Well, I'm not quite sure what's going wrong there. Anybody else, stick your hand up if you're having problems as well. But hopefully it's, well, unfortunately, I'm hoping that it is confined to Nadine. So Nadine, hopefully that'll...
well, I am recording, so that's helpful.
Oh,
maybe try a refresh and just see if that might help. You know, refresh your screen. See if you get the camera ability.
Anyway, have we got right? I actually
other folks are able to do it, so maybe it's a browser issue or something.
A small glitch. Now, actually, Russ, I wanted to. I forgot to welcome all of our new members tonight, but we've got some new students as well, haven't we? Who are joining us for the first time, new students and classes today.
We do. I mean, just this past week. So it's really exciting when a new school comes on board for our astronomy club. So we've got the Great Neck North High School from Long Island. They're just coming on board now. They may have just gotten their accounts this week because this was really fresh. But some of them might be out there, and if they are, hopefully you guys are enjoying the show. And if not, you know, we'll get you out there pretty quickly. We also have a new astronomy club that has formed. It's called the Virtual Astronomy Club. They're in the UK, okay. Paul. Yay. So they may be out there as well. So yeah, welcoming those two new clubs there.
This is midnight coffee here in the UK. So Ross, you're in Texas. So what time is it there?
Yeah, we're doing great here. It's not even dinner time yet, Paul,
I mean, you can kind of spot the folks in North and South America because they've kind of got bright windows.
Yeah, you can see this. You can see the sun shining on the screen behind me. So I'm getting the sunset here. It's actually really great. So.
Now, hopefully everybody can see what I'm sharing at the moment. This is the live stream coming in from the new Chile Lunar and Planetary Telescope. This telescope is, yes, Russ.
Sorry, Paul, I have a question for you. Because I'm just curious, just a little bit about, you talked a little bit earlier about the scopes and their functionality when it comes to the mini moon. When we're looking at one of these supermoons, what are some of the advantages and disadvantages, or what are the advantages of the different scopes that we're using tonight for these particular features?
Okay, so we can flip through them here, can't we? So we didn't actually check conditions earlier, but there we go. I mean, this is the all sky camera, so we can snap an image of that. Sorry, I've got mouse problems tonight for some reason. Right, so let's take a look at one of these. I'm just going to open that up.
We just got a chat message from Ed Easton. He said it's beer 30 in Texas. So
beer 30, that's okay. That's good. So look, here we've got the all sky camera in the Canary Islands. Now, this is a wonderful view. It's a wonderful view because there's a load of white stuff that you can see there, and that's cloud. But we're above the cloud. I got some really cool things actually to share with you later on. But there we can see the telescopes working. So what we can see there, Russ, is once again, everybody, I want you to turn your head on one side because it's a fisheye view. So, but if you turn your head on one side, you're kind of looking normally at the ground. So the ground is on the left, and the white things you see there, those are the domes that we normally see during the day. You can see in the middle dome that there is a huge black bin there, like a dustbin there. That actually is the Canary 1 half-meter telescope. And when we talk about the size of a telescope, we talk about the size, the diameter of its primary mirror. Half meter is 20 inches in old money. How has somebody done that? I don't know how somebody has annotated the screen.
So like someone's better at this than we are, Paul. So
exactly. So anyway, look,
maybe we need to check out our people we've promoted.
Exactly. Yeah. Exactly. Yeah, Todd, maybe you can find out who's doing that and stop them. So that will be rather annoying. So anyway, the half-meter telescope is enormous. It's great for gathering up photons of light from distant faint objects like galaxies and nebulae. For the moon, we actually have to use a very special filter when we use that telescope for the moon, but we're not using it tonight because we don't really need it, which means that members can be using it for galaxies, nebulae, and other stuff. Now, very close to us in this image, if we look on the very far left-hand side, sometimes you can actually see it moving. You see it kind of jump into view, and that's the Canary 2 wide field telescope and ultra wide field telescope. So this is a small telescope on the back of a big telescope, 17 inches, that one. Now for the moon, the Canary 2 wide field telescope isn't used in exactly the same reasons Canary 1. So the only images that we're getting of the moon tonight, if you're on the telescope page, the Canary 2 telescope page, is in the ultra wide field. And let's hop back to that, because this is the one that is giving us tonight So it's got a different field of view. So this enables us to see the entire moon. There's only 2 telescopes, Slooh telescopes, that we can normally do this with, which is Canary 2 ultra wide field and the Chile 1 ultra wide field, which is currently offline. But if you want to take a closer look at lunar features, we can go over to the Canary 4 solar system telescope. And just as its name suggests, this is optimized. It has quite a small field of view, so it only sees a fairly small part of the sky. But that means that objects appear larger in the telescope streams from that, which makes it ideal for close-ups of the moon like this, but also to get close-ups of smaller objects, planets. So it's great at Jupiter and Saturn. I see that somebody's scheduled some Mars missions tonight because we've just re-enabled those. We're going to see how they run. But also for things like planetary nebula. Those are stars, sun-like stars at the end of their lives that are kind of puffed off. So like the Ring Nebula, you get great views in the Canary 4 solar system telescope. So you can start picking out detail of far smaller celestial objects. That's the same thing for the Chile 1 wide field as well. So we get a fairly close-up view, but this is kind of a half and a half. We're not actually seeing the full image here. So if I snap an image of this one, we can see the field of view in comparison. There we go. So we're not quite seeing the entire moon, but we're certainly seeing more than the Canary 4 telescope did. So it really comes down to how much light the telescopes can gather and the field of view, the area of the sky that they cover. And then, of course, we've got 2 telescopes. We've got the Canary 5 solar telescope, which gives us a video feed of the sun during the day. And that is very similar to this Chile 3 lunar and planetary telescope and how that's going to work. I won't be operating every night. It'll operate mainly for special events, but let's just hop over to that again. And oh, look at that. We've gone back down to the bottom of the moon. So does that kind of answer the question, Russ?
Yes, for sure. And one thing I want to point out, and this is something that we really encourage of our members here. And, you know, members have the benefit of being able to take a picture and then look at it later and look at it multiple times. If you're watching tonight at home and you're not a member, that's great. You can still make some really great observations, but we really encourage people to, you know, really start with what you're seeing. You know, think about, you know, put yourself into Galileo's shoes. You know, when he first peered through a telescope, you know, he's drawing the pictures to save them. We're able to snap them and save them to look at them later. But really, you know, every image that you see, start with what you've got. Start with what you can see. Make your observations about what you see and let that lead you to more questions. And maybe you are looking at one image on one telescope. You make your observations on that telescope, switch to another feed. You can do this if you're on your Slooh account. You can switch through the different feeds and make different observations and see how those observations overlap and see how those observations, maybe your next image that you look at answers some of the questions you had from your first images that you were making, observations that you were making. So really want to encourage all of you to just look at these images. Yes, they're beautiful, but also go deeper. Make those observations that lead you to the questions that you might have to either ask us or to go and research later, if that's what you're excited about.
Yeah. Now, I just wanted to pull up on that very subject. I wanted to pull up our one of our quests. So do excuse me, my machine's doing lots of things, so it's a little bit slow. But I just wanted to pull up one of the last quests that I did, which was the moon, lunar features. Now, this really encourages you to do exactly what Russ was just talking about there, which was to learn about the moon, learn about various lunar features. So we can see here, we talk about lunar craters, the Maria, those are the seas, those big dark areas. Maybe Russ, you can talk about some of these when we go back to the live feeds. We've got, let me sort out my mouse. We've got mountain ranges, we've got valleys called rills, we've got bright ray systems. That's a great one to be looking at during full moon. It's one of the two features which is good to look at during a full moon. The other one are lunar swirls. But I just wanted to share with you that what you land up with at the end of all of this is your wonderful poster after you've examined it. Now, this is my particular poster here that I've done. Let me just see if I might be able to open.
And don't let Paul fool you. It's going to take you a while to collect these images. And that's really what makes it engaging. That's what makes it fun. And Slooh also gives you points every time you are snapping an image, every time you're liking an image, every time you're writing an observation and sharing it with our community, you're going to earn gravity points. So these quests are they're a lot of fun because you can, along the way, you're putting together and finding all these lunar features, learning about them, collecting these images, making these observations. You're also engaging with other people in the Slooh community and hopefully earning some gravity points, earning some badges, having a nice time as you're enjoying astronomy education out here.
Exactly, and this is why I actually wanted to show you in its kind of full glory. You can go through these quests, and you could, for this, just select an image like the middle one and say, okay, I've got a sea in there, I've got a lunar swirl in there. But what we encourage people to do in that particular quest is to really examine their images and to actually edit their images so that you zoom in on a particular feature. So you can see down there, we've zoomed into an enormous bright ray system, or some of the valleys that you can see, which actually are quite difficult to see when you're zoomed out. So this is when you want to use one of the smaller field of view telescopes like the Canary 4 solar system telescope, because then you can start zooming in and identify, inspect your image, because it's not just about finishing the quest, it's about learning stuff along the way. So what I've done here is I've snapped images from the live telescope feeds, looked at them, inspected them, picked out the best ones I possibly can, edited them, and then used those for my quest. And then you land up with something that actually, I've got this on my wall at home. And that's what you land up with, something you can really be proud of, but go through that learning exercise as well. So.
And I think the thing that I like about this is that you can go through this, whatever, doesn't matter how old you are, how young you are, you can really meet, you're going to meet yourself where you are for these quests, so you can go through this quest as a 5th grader, you can go through this quest as a, 52-year-old, and you'll really meet the challenge wherever it is that you are. So I think that's what's exciting about it. Fun for me. As an educator.
So anybody who's new to Slooh, I have hopped away from the show page, which is what I was on before. And this is the live telescope pages, if you haven't seen these before. So here we are. I've just clicked on the Canary 2 ultra wide field. So Nadine, if you want to snap your image of this, you can come over to this page, the live telescope page, and you should still hear the show in the background, and you can snap your image here. You can also do things like go full screen, and you can put a portal on it and all sorts of stuff in here. But so this is where Slooh members normally look at all of the live feeds. In fact, Russ, I know this is a super flower moon show, but shall we have a quick look and see what's on the other telescopes as well?
Sure. I do want to, there's a couple of questions that we've got popping up here in our chat section. So
let's do those. Let's do those now.
Yeah. So one of the questions was, are they able to move telescopes like remote control? And, these images are optimized for viewing the object that we're seeing. So, and Paul, I don't know if you want to talk about that any further, but I just wanted to let Suleiman know that, that the telescope images are optimized already. And the second question is, are we allowed to assemble raw files to later assemble to our questions? So for our collections. So yes, when you're in your account, whenever you snap a picture using that camera icon, those images are saved into your photo hub for you to use to later assemble into your collections. So yes, any images, if you're in your Slooh account tonight and you're taking images, those images are all going to be saved for you to look at later. And I would encourage you to look at them later. Look at them now, take the pictures, look at them later, make those observations. Oh, and Paul's showing you a photo hub. You can see, I can only imagine how many images are in Paul's photo hub. I mean, how many images are there?
Sorry, I just took a very sharp intake of breath because earlier on I set up a mission to the Orion Nebula. So you can see the images that I've been snapping tonight. But down here is my image. Sorry, my mouse is giving me all sorts of problems this evening. Of the Orion Nebula. And I set this mission up because I did want to just point out to all members at the moment, Orion is rapidly disappearing into evening twilight sky. If you have not set up missions for, I mean, look at this. I mean, this was straight from the live feed. No, this has had no post-processing done on it at all. This is just the image that was snapped from it. It's glorious. But anyway, if you want to capture the treasures of Orion, including the Orion Nebula, you've got the Flame Nebula, you've got the Horsehead Nebula, you need to set up missions over the next week or two before it gets too low to schedule. So make sure you do that. Right, have we got any other questions there? Because Russ, we have got a poll that we want to run as well, which would kind of get us back to Supermoon territory, and we can take some more questions as well.
Well, there is one question I think is really interesting. It says, this is from Andrew Newton. How frequently does the moon's surface change? I.e., when was the last time a new feature was created large enough to change what we see from Earth?
Now, I don't know a specific answer to that, but I have got some interesting information. Have you got a specific answer to that, Russ?
I mean, I don't. My guess would be Tycho. Might be one of the more. It's one of the more recent impacts, but I things are hitting it all the time. To exactly. Sort of answer your question broadly, it's getting hit by meteorites all the time. Micrometeorites are the most common. So, bombardment by stuff in space. The frequency of the smaller objects is things are much more frequently smaller than the larger objects, so the moon's getting hit by small stuff all the time. But maybe the last time it changed its surface, I don't know that, but I would guess Tycho. I mean, that's 100 million years. So that's relatively recent in the history of bombardment for the moon. I don't know, Paul, do you have any other thoughts?
As you say, it's just like the Earth is being continuously bombarded with micrometeorites. Thankfully, the Earth gets protected by them and they just burn up in the atmosphere. But we have seen these transitory lunar phenomena that we spoke about in the last Supermoon show. And some of those thought to be impacts, but there's another explanation for these transitory lunar phenomena. And that is, we believe that there's some gas underneath the surface of the moon. And let me just get back to one of the live image streams of the moon. And we believe what happens occasionally is that this gas kind of explodes out from underneath the surface and pushes up a huge plume of lunar dust. And these have been videoed, filmed by amateur astronomers with their telescopes. NASA is now on the bandwagon. They've set up some constant earthbound telescopes, constantly looking at the moon to track these lunar phenomena. So there are those that happen. But I think to answer that question, it really depends on what telescope you're using or where you are. For example, a lunar astronaut, one of the Apollo astronauts, they would have seen, impacts which would have happened over the last 100 years, probably. Just small impacts of small meteors, because don't forget, there's no atmosphere on the moon, so even the smallest rock can hit the surface. So if you're there, you'd see stuff that was very recent. If, however, you're talking about earthbound, so our observations here, our live image stream here, as you say, we're probably looking at something like Tycho, some of those younger, whiter craters. But there was also some news, Russ, that I read only yesterday or the day before, where there seems to be some fairly recent, almost active tectonic activity that has been observed. I've seen some false color images just over the last week. This new study was released. Now, I haven't read up on it yet. I only kind of saw the headlines of it. But that would be quite interesting, because we do kind of think of the moon as being fairly dead geologically. Senologically, I think is the correct term for that. But this new study shows that potentially there's still some stuff going on. And that although they described it as tectonic, I'm not sure whether that's the correct term for it, because I thought tectonic had to do with, well, maybe it's plate tectonics and that's when it's plates. But, you know, certainly there is the possibility that there is actually still some volcanic or some kind of tectonic activity going on the moon, but not that we can see through earthbound telescopes. So Russ, we got anything else on that?
Well, I know what I'm going to look up after the show, because I'm curious. I had not seen this. No, but I think your answer about perspective is so right on, because you know, right now, you know, we don't think of the moon as an object that's being eroded, but it is in a way being eroded by these micrometeorites, you know, coming in at, I don't know, 20 kilometers a second, you know, on average. And then, you know, that's some serious speed. And when they hit, they're wearing things down, you know. That's why when you see those images of the Apollo astronauts on the moon, and you see those mountains, and those are indeed mountains. They look like little hills, but that's just trick of perspective. But those mountains have been, they're so dome-like, and that's because they've been worn down by this micrometeorite bombardment that just, you know, cuts off all the sharp edges. Like, you know, we have sharp edges here on Earth on our mountains, but not on the moon. They've all been worn down. So yeah, that's a great question. That's a great question.
Now, I wanted to show a few things that people might see on the telescope pages when they're offline.
Paul, I got to back up. We got a question, and this is a good one.
Go.
So you were talking about the outgassing from the moon.
Yes.
The question from Nadine is, what do we know what the gas is?
I don't off the top of my head.
Yeah, and I don't
I'm
either.
afraid. I doubt whether it's methane, because there was nothing biological on there, although my suspicion would be something that's volcanically generated, but that would be an absolute guess at the moment. So sorry, Nadine, you've caught us out there.
Yeah,
so,
that's a good thing. That's a good thing.
It is,
we
because
love it. Now,
exactly.
I want to know
exactly what Russ just said. You know, this is the wonderful thing about astronomy. It doesn't matter how much you know today, there's always something to learn tomorrow. And how many of us are going to now look that up, you know, and see that after the show? But I just wanted to show you a few little things that I love watching at full moon. These are our monitoring cameras, and these are the time lapses, and you'll see these on the offline telescope pages. This is the all sky camera from this afternoon. So let's watch the sunset, because that's the sun that we're looking at there. And you'll see the domes open in a sec. It'll kick off in a second. There we go. It's going to download it. Oh, it was a bit cloudy today, wasn't it? So we didn't have the solar telescope, but it gets, there you go. So it clears up very nicely for tonight's show. That is the sun setting in the west. The west is actually to the right in these images. Watch the domes open, and watch, there's the supermoon rising. And I just love this as a demonstration of how to spot where a full moon is. A full moon always rises as the sun is setting. So the full moon rises in the east as the sun is setting in the west. Now let me show you my very favorite one. Now, I tweeted out a snap from the Pico del Teide cam earlier today, and take a look at this one, because I absolutely love this. So we've got the cloud disappearing. I'll explain more about this image in a minute. We're about to see the shadow cast of Pico del Teide. Here it comes. There it is. Bang, the huge triangular thing. And look, it's pointing directly to the superflower moon rising. Let me show you that again. So what we've got is the shadow cast of this volcano, because the sun is behind us in this particular camera. So the sun's behind us. We see the shadow cast, and it's cast to the east, just where the full moon is rising. I absolutely adore this view. Now, during the day in the offline state, if you want to know what conditions are like, that is a great camera to look at. I've got one more to show you. This is our Panorama. Now, this one shows us the full 360 degrees of the Canary Islands Observatory. All right. Now, we're going to see the sun, the clouds going to clear. We're going to see the sun set in the west, which is the third panel along. And as the sun sets, we're going to see the moon rise in the left-hand panel, the east one. So take a look at this. I love this view. So there's the sun, down, 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 setting, setting, setting. Watch in the east, there's the supermoon rising. How about that as an illustration of celestial mechanics in action? I just love the simplicity of that. What do you think, Russ?
It's amazing. You know, Paul, I'm actually checking out this chat feed, which is, there's tons of fun stuff happening in chat. And, okay. You know, the great thing about living in this particular time is that when you ask a question, quite often that question can get answered very quickly. So Carol has answered the question about outgassing, and I wonder if maybe we could invite her to, I mean, I don't know if she'd be willing to share it with us. She put it into the chat, but I don't know if she'd be willing to share it with us.
That would be very cool.
Carol, would you be willing to talk on our show tonight?
Hi, guys.
Hey.
Hi, Carol.
Hey, Carol.
What did you find out for us?
I just quickly found out for you by Googling.
Thank you very much.
So I knew just as little as you did when the question was suddenly asked. It's a funny thing, Russ. Have you found that you actually know these things, but when questions are sprung on you so quickly and out of
all the time,
you just blank immediately, and then when you see the answer you think, you know. So yeah, no, right. I did not know that off the top of my head either. I just helped you by Googling it quickly.
Put us out of our misery, Carol.
That's right. So remember all of the viewers, they didn't hear the answer. They're still on the edge of their seats waiting.
Oh, okay. So what I Googled, and I hope it's going to be correct, because I just quickly also took the first post that came.
Yeah, don't believe everything you read on the internet.
Yeah, and you can't believe everything, but it sounds more or less okay. They say outgassing events in which volatiles are vented from deep in the lunar interior to the surface, specifically radon, nitrogen, carbon monoxide, and carbon dioxide, may be the result of low-level volcanic or tectonic events on the moon. So, Paul, you had it. You almost had it there with the volcanic and the tectonic.
So as the source. So, you know, because normally when we think about outgassing on the Earth, we normally kind of think about methane because of the breakdown of biological matter, you know, in the soil or Earth. But, you know, that's obviously not possible because it's a bit barren out there. But Carol, thank you so much. By the way, if you're new to Slooh, you may have missed that Carol actually is from South Africa, and she was our first Hubble level member. So if you hop over, you know about gravity points. So every activity that you do, when you do something great and interact in the community, you get awarded gravity points. So if we hop over.
So tonight we're looking at a supermoon, but Carol, you are a superstar.
Exactly.
I'm sorry.
Yes.
That
was very good. That was very good.
It's all about having fun and learning this stuff together. And even if you make mistakes, and this is what is so fantastic about Slooh is beginners, experience, we all help one another and inspire one another. And I mean, there are members on Slooh that are super intelligent, and they help me along and encourage me. So it's wonderful. It's wonderful to learn in this environment.
But this was greatly deserved, Carol, because you've given a huge amount back to the community. So you truly deserve your place at the top of that leaderboard. So anyway, I want to launch this poll before we get too close to the end of the show. Is that okay?
Yes.
So
Yes,
anybody,
yes.
if you've got questions, now is the time to get them in while we show you this poll. So I'm just going to bring this poll up, and you've got to tell me if you can sit.
Well, while you're putting that poll out, I'm going to answer one of these questions that's here.
Yes, do.
This is one I can handle. So you guys can take a look at the poll. But the question was, what exactly do gravity points do for you on here? And I think they just make it fun and interesting, and it's fun to watch your gravity points grow as you accomplish things, as you make observations and you engage with other people on Slooh. I mean, I think it's just a lot of fun. You're not going to be able to spend your gravity points on anything that I know of. That might be coming, maybe there's a gravity points store, but right now gravity points they just make it fun. They make it fun and interesting, and they engaging to get into this. And I have a fifth grader. My daughter's in fifth grade, and she loves to watch her gravity points grow. So let me tell you, it's a great way to engage kids, and I think personally it's fun for me too.
It is, and one of the interesting things with gravity points is when we launched it last year, a lot of existing members who had been around for quite a time, I have to say, including myself, because I'm not much of a gamer, and this term gamification came along, I kind of started thinking to myself, really? But actually, what we've seen is, myself included, but a lot of those members as well, we see them, doing the quests and doing things in the community that earn gravity points, which is absolutely wonderful. And don't forget that gravity points are really a reward for your activity, and especially it's weighted for the things that you do in the community, so how you contribute to the community. So when you ask a question, when you respond to a question, when you share an observation, all of those things are weighted as far as gravity points are concerned. But hopefully everybody go on, Russ.
You know what? Since we've made them all panelists, no one can vote on our poll here.
Oh no, okay.
Only attendees can vote.
Okay, so I'm going to see if we can relaunch the poll. That'll teach us, won't it, to promote everybody.
We've got a question that's not looking at talking about the moon.
Right,
but,
there you go. Done it.
But we do have a question from an 8-year-old. Mayton wants to know what Uranus is made of.
Ice.
So
it's called an ice giant. So we've got two gas giants. We've got the terrestrial planets first of all, haven't we, Ross? Which ones are they?
Those are all of our inner planets, Paul. So starting from the closest, you know, Mercury, Venus, Earth, and Mars. And then
so they're kind of rocket
asteroid belt. Yes.
Terrestrial. Then we've got the two gas giants, actually my two favorite solar system objects. So I don't know if whoever asked, who was it that asked the question, Ross?
The question was asked by Jason.
Jason.
But it was actually his 8-year-old wanted to know.
Okay, so Jason's 8-year-old. I don't know if you know what the two gas giants are. One of them is my favorite, it's Jupiter with its moons. Some of the moons are kind of icy, some are rocky, some are very volcanic. Then we've got a ringed gas giant, Saturn. But then we got what is called the two ice giants, and that's Uranus and Neptune. And just as the name implied, they're made up of lots of ices. Now that's not kind of water ice. There is some water ice there, but there's a whole stack of other gases. And they're so far away from the sun, they're so cold that all of those gases are actually frozen. So Russ, you got anything more to
yeah,
well,
I mean, you know, you mentioned methane earlier, and we certainly have methane on our planet, but we also find methane out there, in those ice giants as well. So, I think when you're looking at the structure of our solar system, we have our terrestrial inner planets, and then we have the asteroid belt, which, it's not like a Star Wars type asteroid belt. These asteroids are really far apart, but they're rocky, and some of them are sort of the smashed something called the planetesimal, which is a small planet that was smashed during the formation of our solar system. And then beyond that asteroid belt, you start getting into the, this is something called the frost line. When you start getting into looking at solar system formation, this is where, we get these colder objects forming out past that line. So yeah, good question. I think we're moving back here into the moon.
We are indeed. Now, lots of people have already voted for this. So our poll was, can supermoons be super when they can occur 3 in a row? So this is the 3rd month we have had a supermoon. And I've argued for a long time. So I was interested to hear what you lot were thinking. I've argued for a long time. How can something be super if it happens 3 in a row? All right, I'd like to see the definition change. So the options we gave you, which might be leading, I'm not a professional pollster, all right? So it may have been leading you along the way. But yes, I'm fine with the existing definition. The existing definition, Russ, have you got off that off the top of your head? If not, I have.
No, go for it.
So it's when a full moon or a new moon occurs within 90% of when the moon is closest in its orbit. So when it's within 90% of its closeness. I haven't put that very well, but that's the existing definition, and that's why we can get 3 in a row like this, because all 3 have just been within that. The middle one, the one last month, was the real supermoon, the big one. That was the closest of the year. So the other option we've given you, and in fact, a lot of people, in fact, the majority of people at the moment, 60%, have said yes, fine with the existing definition. So you're happy. I would ask if people would not annotate on the screen. That would be really cool if you don't do that. So yes, I'm fine with the existing definition. So that seems like everybody's happy that we can have 3 supermoons. Oh, I'm really disappointed with this. I'm disappointed with all of you, frankly. I think I should leave now. But the second one was,
I don't know. I think we've got a great comment here, a couple of great comments here in their chat session. One, the moon is always super, so that's good.
Good one.
But
like
also,
that.
I like Nadine mentioned that the super is just explaining, giving you a perspective on the moon that you're looking at. So she's comparing it to something being tall, something being skinny, that sort of thing. So I like that that way of looking at it, right? Just
I
gives
like
us,
that as well.
So that we know we're looking at something a little bit different than what we might normally.
A little bit different. And the one thing I have always said, which kind of contradicts the other opinion that I've got, is that anything that encourages people to look up has to be good. All right.
Oh, yeah.
And a supermoon, it's got that word. I mean, if you want the technical term for this, it's apogee-syzygy moon. Now, if we sent out a press release saying we're going to look at the apogee-syzygy moon tonight, do you think many people would come along and have a look? But if we say we're going to look at the supermoon tonight, that's where people are going to come along. And does it really matter? I always think, does it really matter how you get somebody into the classroom? No, it doesn't. Once you get them in the classroom, then you can really explain everything.
So Paul, are you saying it's just marketing? This is a marketing gimmick.
Exactly. It's got everybody here so that we can discuss, look at this, investigate it, learn about it together. So that's a really cool thing. But the second option that we gave you here, which is 22% of people, the definition should be changed to the single largest full moon of the year. And I have to say, that's my own personal opinion. That to me would be the supermoon. So in any calendar year, just the largest full moon of the year. That to me is,
Sorry, Paul. There's a question on here, and I think we should. This will be a nice one because we can go back to some of our telescope feeds. So the question is there iron on the moon? And the answer to that is yes, there is iron, and we can actually just by looking at our images of the moon, we can actually determine where that iron is. And so as soon as we get a nice view of it, when you're looking at the moon, you'll see that there's sort of these two basic terrains. One of them is dark and one of them is lighter. So the dark areas there, the Maria, these are the areas where we're going to find the iron on the moon. So the iron is what gives that area its dark color. So these are ancient lava flows, and those lava flows are iron-rich lava flows. There's some titanium in some places in those lava flows as well, but not all of them have titanium. But all that dark area that you see on the moon there, these Maria, these are iron-rich areas. So yes, that's a great question that we had. You know, is there iron on the moon? Yes, there is iron on the moon, and that's going to be interesting and an important aspect. You know, if we when we get back to the moon, and maybe when we get a colony on there, that which would be a dream come true for many people, me included.
It would. When I was a kid, I used to draw lunar bases, and when I used to think about 2020, I used to think I'd be holidaying on the moon. And it didn't quite work out like that, did it? When was the last time we were on the moon? When was the last time that humans set foot on the moon? It's a long old time ago now, isn't it?
It is a long time ago. You know, before I was even born. But it's such an amazing accomplishment, right? But
what did you say then, Russ? Are you making me feel old?
Oh, I'm sorry, Paul. There's another question related to the iron, and I think it's a good one for us to address. The question is, do we ever see the red color if there's iron? So you know, because if you look at Mars, you're looking at those the reddish color, and that's from the iron oxides. Or maybe you've seen you know, iron rusting, or maybe you've seen rocks here on our planet that are iron rich, and those are reddish in color. So we're not going to see that color on the moon, and that's because to get that color, we need for that iron to interact with oxygen. So we're not going to get that interaction. Now, there are minerals of different colors on the moon. So, you know, when the Apollo missions were on the moon collecting samples, you know, they found green and orange minerals, you know, volcanic glasses. So they found some different colors, but we're not going to find iron oxides on the moon.
Okay. I mean, there is water. I was kind of fiddling around there with the feeds there, Russ, but we know that there's water on the moon, so there would be oxygen there. So would it be possible that maybe at the North Pole and South Lunar Pole, where that ice is, would it be possible for there maybe to be that reaction there if there was, you know, some of the iron up there?
Sure. Yeah, I guess you're right. So that, you know, there's the cold traps. So there's areas of the moon where you know, the sun does not penetrate. They're permanently shadowed. So you know, you might get some of those. You know, when a volatile element, and so that's you know, something that might get in there. It's going to be trapped there. So I guess that's true. You might get some of that reaction happening, but not on any. I guess not in any level where we can see it with our telescopes.
Right, and I think you know, that also goes on to something that you were saying just there with the iron there, that potentially that gives us some materials for kind of space hopping, building spaceships out of Earth's gravity that can, you know, make it easy. But of course, if there's water there, even if it's in ice form, that can be broken down, can't it, into fuel. The oxygen and hydrogen, they can be separated and stuff like that.
Yeah, it's an incredibly important find on the moon to have those elements available to us, especially water, especially if we're going to have people there. They can use it for all kinds of things. But you know, if we're able to get to the moon and establish a colony, certainly the escape velocity from the moon is much lower than Earth's. So you know, if we can start manufacturing rocket fuel, and we're going to be able to escape from the moon, and maybe from there jump on to where a lot of people want to go, you know, Mars.
Now, it strikes me that we've got some new members here, but even existing members might not know actually who we are. I'm Paul Cox. I'm still astronomer. I've been around for donkey's years, but Russ is new to us, Russ Glenn. And it struck me just earlier today, Russ, that when you were on the previous show, we didn't actually introduce you properly. So Russ Glenn, you're Director of Education at Slooh. What's your background? Tell members what your background is, why you've joined Slooh, and yeah.
I'd be happy to. Before I do that, though, there's another question in chat that I think we should address, because it's one that I think is important to talk about. Pete mentions that the full moon is actually, from his perspective, not the best time to observe the moon.
Yeah, absolutely.
And he's got a great point, because you know, if you're looking at the first or last quarter, you're getting the shadows, and so you're getting a really good view of the relief of the moon. I mean, so much of the time we look at the moon and we think of it as being sort of this, not having a lot of relief, but it actually has the same relief as the planet Earth, from the deepest craters to the highest mountains on the moon. So it's got a significant amount of relief, and you can't really see that with a full moon, but you can get a nice view of that relief when you have when the terminator line is on a different part of the moon. So the first and last quarter, and I think Pete makes a really great perspective. There's actually an International Observe the Moon night that happens every year, and it's not going to be during a full moon, because you're exactly right. The full moon is not the ideal time to observe the moon.
Exactly.
So thank you for that question.
Yeah, and actually it can be quite difficult to observe if you try and use binoculars or a telescope visually,
yes,
because it can actually be quite blinding. And as you say, it really demolishes any of that relief and contrast. And I've just pulled up here. This is from our lunar phase quest, and you can see, if you zoomed into this, you can see exactly what Russ was talking about. Along that terminator, when you've got that shadow, when you've got all of that lovely contrast, you can see a huge amount of detail. But just looking at the full moon image that I snapped there, and our live ones tonight. Let's go back, because let's go back to our Canary 2.
I'm going to address one more question while you're navigating, Paul.
Yes, go.
Michael asked, why does the full moon glow so much? And I could answer that, although it might be kind of fun. Does any of our folks who have been elevated to panelists want to tackle that one? Why does the full moon glow so much? If not, I'll happily take it. But anybody want to pipe in? You can just unmute yourself and say it live on the internet. No one? Okay. So the full moon is reflecting the sun's energy. So the sun's energy, and it's from our perspective, this full moon is the term syzygy is this lineup of celestial objects. So basically, the sun, the earth, and the moon are lined up. Now there's some inclination to that as well, because the moon is not directly in a line with the earth. So that's why we're getting the full moon. But the face of the moon that's towards our planet is getting the full force of the sun's energy, and all that energy is hitting it and then bouncing off and bouncing back towards our planet. And that's why it's so nice and bright. Sean Hutchison mentions a moon filter helps for full moon viewing if you're using your home telescope. And that's very true. I guess. Indeed,
and
yeah, go ahead.
We do. I mean, the telescopes that we're using here, so the Chile 2 ultra wide field, the Canary 2 ultra wide field telescope, the Canary 4 telescope that we've been looking at here, we've had to use some very special filters that cut out about 99% of the light from the moon, because don't forget our nighttime telescopes are designed to collect, you know, tiny, tiny amounts of light from faint objects. So you pointed at one of these things, and we actually have to throw away most of that light, reject it. So that's what we have to do with this. Yeah. I was just going to have a quick look at observations, Russ.
All right, I should introduce myself. You asked me to introduce myself.
Yes,
I went into a totally different direction.
Tell us who you are.
Carol's reminding me. Introduce yourself. So yes, my name's Russ Glenn. I live just outside of Austin, Texas. So and I'm a career educator. I've been in the classroom for many years. I've also been in what's called informal education. So I've taught outdoor education. You know, my passion for astronomy really has come from my educational experiences. So, you know, when I was in 6th grade, I had a teacher who introduced me to Halley's Comet and got me really excited about that. And what really grabbed me though, and this was actually, I studied geology, environmental geology in college, but really grabbed me for astronomy was Hale-Bopp. Was seeing the comet Hale-Bopp. You know, that was 96, 97, I think. And that really roped me into astronomy. And then I've just been, but I've been teaching environmental science. I've been teaching astronomy. Been teaching physics. I've been in the classroom for a long time, and come into Slooh because I believe in their mission to get astronomy education to as many people around the world as possible. I think that cosmic perspective is so important, and we're getting a bit of that tonight. Certainly, the moon is a great gateway to getting excited about space because it's the thing you're always going to be able to see it. It's always there. You know, even when it's a new moon, and it's still there.
And you know, if there are teachers, students, parents, grandparents who have grandchildren or whatever, if anybody's interested in getting involved, then you're the person to talk to from the educational perspective, aren't you, Russ? Do you want to give your email address out?
Yeah, I am. And I would love to hear from you. It's russ@slooh.com. And I do want to mention something exciting. I mentioned a couple of our new astronomy clubs. But I also want to mention that we're going to be having an online space camp. So that'll be happening. Our first session is going to start June 8th, and it's included with your membership. So if you're a member, awesome, you can join us. If you're not a member and you want to do that, or you want your kids to have a chance to be part of our online space camp, become a member, join us, go to slooh.com and join up. We'd love to have you. Be on the lookout for more details about that. But we're really excited about that.
It is. It's going to be so cool. I just wanted to kind of finish us off here. We still got some live views in the telescopes of this super flower moon, but I did want to share this. You probably saw me. I was hopping through shared observations. So these are observations. Just to let people know as well, what observations are about is capturing a moment and sharing that particular moment with the rest of the membership. So what makes it special? You know, it's not just this is a lovely image kind of thing, but this is new member Parag, who a lot of you have probably seen, been sharing some wonderful stuff. And this is his capture of the moon. I can't see, I'm guessing it's from, can't see down there actually. Let's have a look. Which telescope? Canary 4. So it's a Canary 4 solar system telescope. So that one that was giving us those really lovely close-up views tonight. But what he's done is he's done a little bit of post-processing on it, and we land up with this incredible detail. And this is what Russ was saying earlier. So we can see here that this was not the full moon, this is a few days ago. So we've got the terminator down there. You can see the shadow that we've got in these craters and in the mountain ranges, and we can see those valleys and stuff like that. I just wanted to share that with you to kind of be an illustration of the difference between observing a full moon through the telescope and observing the lesser phases. And at the beginning of each month, actually, when the new moon is only about it's normally between 2 and 4 days, we set up special missions that only occur in the first mission slot of the night, when it's just rising, of the thinnest, youngest crescent moon you can ever capture with the Slooh telescope. So keep your eyes open for that, especially if you're doing the Lunar Features Quest. So Russ, what else have we got to talk about before we wind up tonight's Star Party Live?
First of all, I would frame this picture and put this on my wall. This is phenomenal. But there's a question. How was the moon formed? And I think this is maybe a good way to wrap things up, talking a little bit about lunar formation. And then I would really encourage you, especially those of you who asked this question, we're going to go through this real quick. But if you go to our Cosmic Explorer Quest, you can find out more about lunar formation. So, you know, as the solar system was forming, and we're forming these things called planetesimals. So these are, you know, gravities pulling stuff together, coalescing the stuff that was around the proto sun, the early sun. So, you know, what we had is something that was going to become the Earth. Was in orbit around that sun, and another object about the size of Mars, so smaller than our planet, came in and just smacked it. So some people call it the big whack. I kind of think that's kind of fun. But you know, it was a collision, and that collision ejected material from that early Earth out into space, and that material coalesced to form our moon. And there's a lot of, you know, there's a lot of evidence whenever there's a scientific model or scientific theory, there's a lot of evidence supporting that. So, you know, if you look at the composition of the moon, it's, you know, it's got a very small amount of iron. We certainly can see some of it on the surface, but a very small amount of iron compared to sort of other planets that would be comparable to our own crust and mantle. So there's evidence for this. And this is the current model, is that there was this big collision that ejected material from the Earth, what will become the Earth, out into space, and that stuff coalesced due to gravity to become its own object. And in some ways, when we look at the Earth and the moon, you know, they could really almost be categorized as two, almost a double planet system. You know, the moon is very large compared to its host planet. So yeah, that's a... Paul, do you want to add anything to that or wrap us up?
I only from the point of view that I would encourage people to look up lunar formation theory and history, because the evolution of our understanding over the last 150 years about how the moon formed has been fascinating as the scientific evidence has accumulated. And of course, it was the Apollo missions when we landed up getting our hands on some moon rock that really unlocked the big secret, because we were able to analyze what the moon was made of and compare it to what the Earth was made of. And that's where, you know, some of that evidence started building. So,
and if you've got some time, Paul and I discussed that whole thing in more detail during the Cosmic Explorer lesson that we did a month and a half ago. So you could look that up. Cosmic Explorer astronomy lesson number one from Slooh. That was a lot of fun. So, and this has been a lot of fun.
Exactly. Unless anybody has got any last questions, we should wind up tonight's Super Flower Moon Star Party Live. In the meantime, it's good for us to tell you that if you have got any ideas for a Star Party Live topic, doesn't have to be a big event like this, doesn't have to be a humongous. I know a lot of members didn't like me using that word humongous, near Earth asteroid, or a supermoon. It could be that you just want to get together with another group of Slooh members and look at the live image streams, discuss what's coming up, maybe theme it. Maybe a group of you get together around your club. I don't know, let's think for the Love of Lunar Club, or maybe the Solar, Our Sun Club. You know, if you want to get around the live feeds, schedule submissions to talk about, you know, So it might be about nebulae. You're all interested in nebulae or bright stars or something like that. And we can set that up and facilitate it for you. So do let us know. You can email Russ at slooh.com, or you can email support@slooh.com, or you can email me at paul@slooh.com. So any last questions there, Russ? Otherwise, we're going to wrap it up.
Let me take a quick look. Nope. A lot of thanks. Great show. We appreciate that. Awesome.
Well, thank you all for joining us. That's the big one, and thank you all for, or mainly for holding back and not annotating the screen too much. You know, we didn't quite realise that you were able to do that if we promoted you to panelists. But anyway, listen, we will see you in Slooh chat, which is up here. If you haven't seen it, if you're a new member, so many circles, is there a hypothesis about that? All those people have been asking some questions in there. Don't forget, alert notifications in here. This is where you see status information. So the Canary Islands is open 1, 2, 3, and 4 online. That's always a good sign. And Chile messages is not up there. I would like to give some huge thanks to Russ for being here to help me out while I'm screen sharing and stuff like that. To Todd, we can see Todd there. He's been running things there in the background, and he's the guy who promoted you all. So a round of applause for Todd. Thank you.
Great show, Paul and Russ.
And also behind the scenes, we have Andrew Dumbleton, Slooh's operations manager. So he's the guy who posts all of those things. He's been operating the Chile 3 solar telescope tonight. If I can get that running, just for our last little live look through the Chile 3 lunar and planetary telescope. Is it still running? Is Andrew still there? No, it's blacked off. So I don't know what's happened there. But anyway, thank you very much, Andrew.
It'll come back, Paul.
Oh,
there he goes.
And here is Andrew. Andrew, you're on air, so thank you very much. And you've come down to still this little bit of waxing gibbous, because I think what we said at the beginning of the show, it's going to be full in a little bit of time. You know, we've got another 9 hours or something until the moment of full moon. It's the night of full moon, but the moment, and that's when we're going to lose all of these lovely shadows of these edge-on craters and stuff like that. So,
well, and thank you, Paul. Thanks for leading us through this. This has been a lot of fun. I know I learned some stuff. This is great. I love it.
Exactly, and we've all got some stuff that we're now going to look up and Google and Wikipedia and everything else. So share that over in the Love of Lunar Club if you find out any more information. But for now, that is the end of Slooh's Star Party Live, the full flower moon. That's the last supermoon of 2020. But don't forget, a little bit later on in the year, I think it's around October time, we've got the mini moons. Some people call them micro moons. I prefer mini moon. When the moon is going to appear, the smallest of the year. So hopefully you've snapped some images of this super moon, because then you're going to be able to make this kind of comparison between a mini full moon and a super full moon. I hope you've enjoyed it tonight. We've enjoyed your company. Listen, on future Star Party Lives, we really want you lot to get involved, you know, and come on and discuss stuff with us. So don't hold back, because we're all learning, as Russ just said there. We all learn stuff. You heard us. We're never afraid to turn around and say, actually, don't know the answer to that, but we can find out. And thankfully, members like Carol and anybody else comes along to help us. I can see there we've got a budding young astronomer there. Hello to you. I hope you've enjoyed tonight's show, and I hope everybody's enjoyed tonight's show. That's it from us. Good night, Sloohs. Bye, everyone.
Good night.
Bye.